Did you know that the most dangerous thing sitting inside your tiny home right now is not your propane tank, not your electrical panel, but a battery bank? I know, that sounds crazy, but stay with me for just 60 seconds, because this might completely change how you think about powering your home. Lithium batteries have been the gold standard for off-grid tiny homes for years. Solar panels on the roof, lithium bank in the closet done. And for a while, that setup made total sense. But in 2026, cracks are starting to show in that model. Big ones. The price of lithium fluctuates wildly with global supply chain politics. Battery banks degrade, sometimes faster than the warranty promises. And even with the industry's shift toward LFP chemistry that removes cobalt, we are still tied to an enormous environmental footprint. Lithium extraction alone is now impacting over 250,000 hectares in 2026, specifically in the lithium triangle across Chile, Argentina, and Bolivia. That is soil degradation, water table disruption, and biodiversity loss at a staggering scale. So what is the alternative? What if your energy storage had no chemicals, no fire risk, no rare earth mining, and could theoretically outlast your entire tiny home? What if it ran on nothing but physics? That is exactly what we are talking about today. Gravity-based energy storage and flywheel systems. The technology that major energy researchers are calling the most promising alternative to lithium ever developed. Before we dive in, if you are new here, welcome to Affordable Tiny Homes, where we skip the hype and give you the real data. Hit subscribe and tap that bell so you never miss a video, because later in this one, I am going to reveal the hidden cost math that most tiny home builders never run, and it could save you serious money over the lifetime of your build. You will not want to miss that. Let's get into it. Let us start with an honest look at what is actually going on with lithium batteries in 2026, because the story is more nuanced than most YouTube channels will admit, and I think you deserve the full picture. Lithium-ion batteries are genuinely impressive technology. High energy density, relatively compact, widely available. For most tiny home builders, a lithium bank paired with solar is still a perfectly reasonable choice. I'm not here to tell you that lithium is the enemy. What I am here to tell you is that it is not the only choice, and for some of you, it might not even be the best one long term. Here is where the conversation has evolved in 2026. The most common battery chemistry for tiny homes right now is LFP, which stands for lithium iron phosphate. And LFP has genuinely solved one of the big ethical problems of older lithium chemistries. LFP batteries are cobalt-free. That is important because older lithium formulations relied on cobalt, most of which came from the Democratic Republic of Congo under conditions that raised serious labor and safety concerns. So credit where is due. LFP is a cleaner, safer chemistry, with better cycle life and no thermal runaway risk. If you are running LFP right now, you made a smart choice. But here is what the industry does not talk about loudly enough. Even without cobalt, the environmental cost of lithium itself is massive and growing. Lithium extraction in 2026 is impacting over 250,000 hectares of land, concentrated in the lithium triangle of South America. The extraction process depletes underground brine aquifers, disrupts local water supplies and some of the driest ecosystems on Earth, and produces significant carbon emissions through the refining process. About 40% of the carbon footprint of a lithium battery comes before it ever leaves the factory, from the mining and refining of active materials alone. And then there is the reality of cycle life reality. A typical LFP battery will give you somewhere between 3,000 and 6,000 cycles before meaningful degradation, which is better than older lithium chemistries, but still translates to a replacement event within 10 to 15 years for most tiny home applications. None of this means you should tear out your battery bank, but it does mean we should be genuinely curious about what else is possible. And what is possible turns out to be incredibly fascinating. Okay, so let us talk about gravity storage. And I promise this is not as complicated as it sounds. The concept is almost embarrassingly simple. When you have excess electricity, maybe from your solar panels on a sunny afternoon, you use that electricity to lift something heavy. A weight, a block of concrete, a mass of some kind. Then when you need power back, you lower that weight, and the kinetic energy of it falling drives a generator that produces electricity. It is basically the same physics as a grandfather clock, but scaled up and connected to your home. This is actually how pumped hydro storage has worked at grid scale for decades. Water is pumped uphill when there is excess power, then flows back down through turbines when power is needed. Pumped hydro accounts for the vast majority of grid-scale energy storage on the planet right now. The difference with modern gravity storage systems is that they swap the water for solid weights, which means they can theoretically be deployed almost anywhere without the need for mountains, valleys, or large bodies of water. Here is how serious this technology has become. The global gravity energy storage market was valued at approximately $1.59 billion as of mid-2026 and is projected to reach nearly $46 billion by 2040. That is a compound annual growth rate of over 27%. This is not a niche curiosity. This is a technology receiving serious capital from serious investors. As of 2025, over 18 pilot projects and 12 commercial-scale plants were already operational worldwide, contributing roughly 1.8 gigawatt-hours of cumulative installed capacity. The market is growing fast. The biggest name in the gravity storage space right now is Energy Vault, which trades on the NYSE under the ticker NRGV. They use massive blocks of composite material that are stacked and unstacked using cranes, storing gravitational potential energy at scale. And here is something that makes you sound like a true industry insider if you mention it. Energy Vault has pivoted their 2026 strategy in a significant way. Instead of just selling towers to utilities, they are moving into what they call the asset vault model, where they own and operate the storage assets themselves. That is a major shift because it means they are betting on the long-term cash flow of the technology, not just on selling equipment. Their newest G-Vault deployments in 2026 are hitting a storage cost of around $90 per megawatt hour, which is now cheaper than new coal generation in most regions of the United States. Other players include Gravitricity in the UK, which focuses on using disused mine shafts for vertical weight drops, Ares, which uses inclined rail systems in mountain terrain, and Green Gravity, which is doing pioneering work in repurposing abandoned mine infrastructure. These are not garage startups. They are receiving serious institutional investment and deploying real projects. But here is where it gets really interesting for the tiny home world. Now I have to be completely transparent with you here, because this channel is built on honest information. The large-scale gravity tower systems I just described, the Energy Vault stuff, the mine shaft systems, those are not something you're going to install behind your 200 square foot tiny home next year. Those are utility scale and commercial scale technologies right now. Their minimum viable deployment is measured in megawatt hours, not the 10 to 20 kilowatt hours a well-designed tiny home actually needs. But there is a cousin of technology that is starting to look genuinely relevant for residential and off-grid applications. And that is the Flywheel. A Flywheel energy storage system works like this. When you have excess electricity, you spin a heavy rotor inside a vacuum-sealed housing at extremely high speeds. That spinning rotor stores kinetic energy, which is rotational energy, much like a spinning top. When you need power, you slow the rotor down, and that kinetic energy gets converted back into electricity. The result is a system that stores electricity as physics, as spinning motion, rather than as chemistry. No lithium, no cobalt, no thermal runaway, and crucially, no meaningful degradation from charge cycles. Here is the comparison you need to understand clearly. And I'm going to give you the honest 2026 numbers. On upfront cost per kilowatt hour, Flywheel systems currently range from $1,500 to $6,000 per kilowatt hour. A high-quality LFP lithium setup for a tiny home runs roughly $400 to $600 per kilowatt hour. So yes, Flywheels are significantly more expensive to buy today. I'm not going to hide that. But here is where the math changes completely. The metric you actually need to be looking at is called LCOS, the Levelized Cost of Storage. This accounts for upfront cost, lifespan, replacement cycles, and ongoing maintenance over the full life of the system. And in 2026, the LCOS for Flywheel systems is hitting approximately 3.8 cents per kilowatt hour. For lithium, including replacement cycles, it remains around 11 cents per kilowatt hour. That is nearly 3 times higher when you do the full life math. Think about what that means. The lithium system looks cheaper on day one. The Flywheel system is dramatically cheaper over the 25 to 30 year life of your home. Lithium LFP 3,000 to 6,000 cycles, roughly 10 to 15 years of real-world life. Residential Flywheel, 100,000 or more cycles. Design life of 25 years or more with minimal maintenance. No replacement cycle. Modern flywheels can achieve round-trip efficiencies of 85 to 90%, comparable to advanced battery systems. They respond in sub-seconds. And unlike lithium systems that can throttle peak current during high-demand moments, a flywheel can deliver very high power for short bursts without any degradation, which matters practically for starting a well pump, running a microwave, or handling the startup surge of a mini-split compressor. One startup worth watching closely is KineticCore Solutions and their 2026 Kinetic battery product. This is one of the few flywheel systems actually aiming at the mid-market rather than just the utility sector. The Kinetic battery can deliver over 250 kilowatts of power with no degradation over a 25-plus year lifespan. KineticCore claims up to 60% lower upfront cost compared to traditional flywheel solutions and up to 85% reduction in operational expenses over the system lifetime. For a 5 kilowatt-hour flywheel buffer unit in 2026, the realistic entry point is around $15,000. That is expensive today, but it is a 30-year asset. When you think about it that way, the conversation changes completely. The honest, real-world advice from engineers working in this space is to think about flywheels and batteries as a team rather than as competitors. The flywheel acts as your power booster, your instantaneous response system. The battery, if you have one, handles longer duration overnight storage. That hybrid approach gets you the best of both. But keep watching, because the third piece of this puzzle is where it all comes together for tiny home builders specifically. Here is something the mainstream housing conversation is missing completely. Tiny homes are not a liability in the transition away from lithium dependency. They are actually an advantage. Think about it. A conventional 2,000 square foot house has enormous energy demands. HVAC systems, hot water heaters, multiple refrigerators, entertainment systems, the whole package. The energy storage requirements are massive, and the economics of alternative systems are harder to justify at that scale right now. But a well-designed tiny home, your total load is dramatically smaller. A good build in 2026 running efficient LED lighting, a mini-split heat pump, a compact refrigerator, and a few other essentials might peak at 3 to 5 kilowatts of demand. That changes the math on alternative storage completely. Researchers are now developing what is being called hybrid gravity kinetic storage. The concept combines a gravity component for multi-hour bulk storage with a flywheel component for instantaneous power response. The flywheel handles the fast variability, the startup surges, the frequency regulation. The gravity module handles the overnight storage, the cloudy day backup. According to analysis from research published in late 2025, this hybrid architecture may solve several limitations that batteries, standalone gravity systems, and even pumped hydro have struggled with individually. It is the combination, not the individual components, that makes it powerful. Some of the most innovative work in small-scale gravity storage involves repurposing existing vertical space in buildings and on properties. Canadian researchers have proposed building integrated gravity systems that could achieve a levelized cost of energy ranging from about 5 cents to 11 cents per kilowatt hour. Combined with flywheel LCOS numbers of around 3.8 cents per kilowatt hour, the blended economics of a hybrid system start to look genuinely competitive with lithium on a full-life basis. Picture this: a tiny home on a rural property, solar panels on the roof. Underneath the home, or in a small mechanical shed nearby, a compact flywheel unit from a company like KineticCore. That flywheel handles the instantaneous demands of daily life. Every light switch, every appliance startup, every power surge. For overnight storage, a gravity component using a raised weight on a vertical rail stores the energy captured during peak solar hours and releases it slowly through the night. No lithium, no replacement cycle every decade, no supply chain ethics problem, just physics. This is not science fiction. Analysts expect the first accessible commercial-scale gravity storage products to reach the broader market between 2026 and 2028, with wider adoption potentially emerging in the early 2030s as costs decline. We have seen this exact curve with solar panels. We saw it with lithium batteries themselves. gravity, and flywheel storage are on the same trajectory. And that timeline matters for decisions you are making right now. Okay, let us get practical, because I know that is why you are here. What does all of this mean for your actual tiny home build or your existing setup in 2026? Here is my honest take, and this is based on real 2026 data. If you're building right now and lithium LFP is in your budget, do not panic. LFP lithium is still a perfectly functional choice for most tiny home builds in 2026. The technology works. It is widely supported. Installers know it is cold. The cobalt problem has been addressed with LFP chemistry. If you are building today and need a storage solution you can spec and install with confidence, LFP is your most reliable current option. But here is what I would do differently if I were building today. First, design your electrical system with modularity in mind. Leave physical space and electrical infrastructure headroom for a future flywheel or gravity component to be added later. The switchover does not have to happen on day one, but locking yourself into a configuration that cannot evolve is the mistake that will cost you money. Second, pay close attention to the gravity storage and flywheel sectors over the next 24 to 36 months. Energy Vault, Gravitricity, KineticCore, Green Gravity. Watch what products they bring to market. Watch the price points they hit, and watch what the off-grid and tiny home community start saying about real-world performance. The market is moving fast. Third, if you're an early adopter type building a permanent off-grid homestead where you plan to stay for 20 years or more, run the LCOS math before you commit. At 3.8 cents per kilowatt hour for flywheels versus 11 cents per kilowatt hour for lithium over a full system life, the numbers start telling a different story than the sticker price suggests. Here is a number to put in your mental model. The gravity-based energy storage market is projected to grow at a compound annual growth rate of 61.5% between 2025 and 2034, reaching $3.2 billion from just $42 million in 2024. That is the kind of growth curve that drives price compression fast. We have seen this pattern before with solar panels and with lithium batteries themselves. Gravity and flywheel storage are on that same curve, and the window to be an early informed buyer rather than a late majority buyer is opening right now. Which brings me to the thing I promised you at the beginning of this video. Remember at the start I said I was going to show you the hidden cost math that most builders never run? Here it is. The real cost of lithium storage in a tiny home is not the purchase price. It is the total cost of ownership across the lifetime of your home. And almost nobody calculates this before they build. Let us say you spend $8,000 on a quality LFP battery bank for your tiny home. That is a realistic number for a system sized for comfortable off-grid living. Over 10 to 15 years, that battery bank has degraded enough that it needs to be replaced. Another $8,000, maybe more if prices rise. If you own that home for 30 years, you are replacing the battery bank at least twice. You are now at $24,000 in storage costs, and that is being conservative. Now run the flywheel math. You spend $15,000 on a quality 5 kilowatt hour flywheel buffer unit today. That is your entry point. In 30 years, if the engineering holds and the data says it should, that system is still running. You spent $15,000. Total. The lithium path costs $24,000 over 30 years. The flywheel path costs $15,000 over 30 years. And the flywheel path wins on the LCOS metric at every point in that comparison. 3.8 cents per kilowatt hour versus 11 cents. I am not telling you this to say you should drop everything and go buy a flywheel system today. The product availability is still limited and the technology is maturing. What I'm telling you is that the builder who designs with no room to evolve will be paying that replacement cost on a loop. The builder who thinks ahead will have options. Physics-based storage has one thing going for it that chemistry-based storage will never have. It does not age the same way. Gravity does not degrade. A well-made flywheel does not forget how to spin. And in the world of tiny homes, where every dollar and every square foot matters, that kind of durability is not just impressive. It is genuinely revolutionary. So there you have it. Gravity storage. Flywheel systems. The hybrid architecture that researchers are calling one of the most promising paths away from full lithium dependence we have ever developed. Is it ready to replace your battery bank tomorrow? Not quite. Is it the direction the smart money and the serious engineering is moving? Absolutely. If you found this useful, please hit the like button. It genuinely helps this channel reach more people who are trying to build smarter, build cheaper, and build with a lower footprint. Drop a comment below. Are you currently running LFB in your tiny home or off-grid setup? Have you been thinking about alternatives? Are you hearing more about flywheel systems in your builder community? Let me know where you are in the process. And if you want to go deeper on off-grid energy systems for tiny homes, I have a full video on passive solar design and energy efficiency that pairs perfectly with everything we covered today. I will link it right here.